Okay, so this video is going to be guiding you through the handout Solve Problems with Trigonometry. So last week we looked at primary trig ratios and how we can only use those for right triangles, so sine, cosine, and tangent. And then yesterday we looked at sine law and cosine law. So this video is for Tuesday, June 21st, and Miss Ryder has been left a list of questions for you to work through over the next couple of days. So this video, I'm going to guide you through some of these questions, developing strategies for these questions, and how to pull out the necessary information to solve for missing sides or missing angles, depending on whether it's a right triangle or an acute triangle. So this will be the only video, just because there's really only so many questions you can be guided through. The rest you're going to have to try and work through, look through your notes, and try and get practice at this skill. Get practice at taking the information out, creating a diagram if it's not given to you, and then solving. Tomorrow, which if you're watching this on the proper day, should be Wednesday, June 22nd, you will have another set of questions to practice. Same thing with Thursday. So I know that I've kind of turboed through this unit very quickly because I wanted to be able to teach all of it. So I'm giving you 3 days to practice and 3 days to consolidate all these ideas together, learn how to solve these questions so that you're ready for your unit test, which will be on Friday. I will be checking my emails as often as possible while I'm in Nashville, so if you do have questions, please send them to me, but I suggest that you use these 3 days wisely. This is your last unit test, make it count. So use these next 3 days wisely to practice as many questions as you can, and I'm going to leave you with copious amounts of questions so that you can get practice. So these questions are actually going to take both skills for acute triangles and right triangles all into account. So we're going to mix all of those things together. So let's take a look at the first question. It says, to measure the height h of an inaccessible cliff, a surveyor records the data shown. Find the height of the cliff to the nearest meter. So if we look over here, and I know you have it in front of you, but I'm going to just kind of show you what I'm looking at. So we've got h, which is the height, and we have 3 angles known. So we've got a right angle here, which we know because the cliff and the ground we can assume are going to make a 90-degree angle. So we're given a right angle here. We know that this angle is 30.5, and we're given 2 over here as well. So what we're trying to find here is h. And in order for us to find h, we see that it is a right triangle, so we'll be able to use primary trig ratios to solve for h. But in order to use a primary trig ratio, you need a angle and a known side in order to find that other unknown side, or 2 sides to find an angle. Well, in this case, we're trying to find a side, so we would need to have an angle and 1 known side. We have an angle, right? We know 30.5, but we don't know any of the sides. So we can't solve this right triangle because we don't have enough information. If we shift over to this other triangle, though, we should be able to extract some information from there. So first thing you should notice by looking at it is that it's not identified as a right triangle. So we can't use primary trig ratios. We would have to use either sine law or cosine law. In order to do that, the first thing I would want to do is make sure that you can complete as many angles as possible before you look at anything. So you know that triangles add up to 180 degrees. You're given 2 angles, so it's very easy to find that third angle. You just subtract both of those values from 180, and you would get 65.6. And I haven't shown me actually writing that down because I think you all can subtract 2 numbers from 180. So we know all 3 angles within that triangle, and you see that none of them are 90 degrees, so it's not a right triangle. It is an acute triangle. All 3 angles are under 90 degrees. So we would have to use either sine law or cosine law. Now, what we want to do with sine law or cosine law is find a missing side on this triangle so that we can use primary trig ratios to solve for h. Obviously, we're not going to try and find this angle, this side, because it's not attached to this triangle, so it's not going to give us any information. The only side that is part of both triangles is this one. So if we use the information here, we can solve for this missing side and then use that in a primary trig ratio to find h. So if you remember what we talked about yesterday, deciding whether or not to use sine law or cosine law depends on what information you're given. In order to solve for, or using sine law, you would either have to have 2 angles and a side, or 2 sides and an angle. In this case, we have 2 angles and a side, so we should be able to solve for that missing side. So if I name this, I'm going to go A, B, and C. And I should be able to develop a relationship. So I want to find side B, which is right here. So this is side B. It's opposite angle B. So I have angle B. Side B is what I'm trying to find. I have angle A, and I have side A. So because I've got two sides in an angle, I can use sine law. If you remember sine law from yesterday, it would just be the side, so the value of the side over the sine of that angle. You can put that into a fraction, and they're all equal to each other. So we can say that A divided by sine of A is equal to B over the sine of B. So if I go back, angle A is 65.6 and side A is 185. So I'm going to say 185 divided by the sine of, what was it? 65.6 is equal to, is equal to side B, which is what we don't know. That's what we're trying to find. Sorry, this is hard to videotape and write at the same time. So side B, which is what we're trying to find, over the angle, which would be 49.3. So the sine of 49.3. So we're going to solve for B. So we talked about yesterday cross-multiplying. So we cross-multiply these guys and we cross-multiply these guys. So we're left with sine of 49.3 times 185 equals the sine of 65.6 times B. Isolate for B, we're going to divide both sides by sine of 65.6. Obviously, this is going to be quite a complicated calculation to put into your calculator, so just make sure that you're doing it properly. So I would hit sine 49.3, hit equals, then multiply it by 85, hit equals again, then divide by sine of 65.6, because if not, it's going to get BEDMAS wrong, and it's going to end up taking sine of 49.3, and then it's going to end up multiplying it by 185 divided by 65.6, which is not the same thing. So make sure you do that in the proper order. So these guys cancel out, and B equals 154. I've pre-worked all of these out, so you should just be following along and doing this on your calculator. So now we know that B, side B, is 154. Now, again, we're trying to find H. Well, H is part of a right triangle, so we don't need to use sine law or cosine law for that question. We can just use primary trig ratios. We have what we need for a primary trig ratio. We have an angle and we have a known side, so now we can find that unknown side. So I'm working with respect to this angle, and with respect to this angle, what do I have? Well, I have B now, which would be adjacent, because we know that this is the hypotenuse, and I'm trying to find H, which is opposite. So I'm working with adjacent and opposite. If I write out SOHCAHTOA, which primary trig ratio deals with both opposite and adjacent, you should see that it would be tangent. So tan of 30.5 is equal to opposite, which would be H, because H is across from that angle. So I would have H over 154, which would be side B, which is what I just found. I cross multiply those, and H is going to be 90.7 meters. So the height of the cliff in total is 90.7 meters. Okay, that's a beautiful question because it takes both primary trig ratios and sine law and cosine law into account. So of course that's something you can expect to see on the test, because you know how I love to give you challenging questions on the test, and I know that you love it. Let's try number 2. So it says 2 hotels are located on the same side of a river, 400 meters apart. There is a ferry dock on the other side of the river as shown. How wide is the river? Okay, so one thing to note is that the angle here and here are different. So you don't have an equilateral triangle. So you can't assume that from hotel 1 to here and here to hotel 2 are each 200. Right? You can't split that in half. If these were the same angles, then you could make that assumption. But because they're not the same angle, they're not equilateral triangles. So you can't make that assumption. So we're going to have to find what these sides are for each of those individual triangles. Okay? We can assume that this is a right angle. That's fine because we're measuring straight across. So you can assume that it's a right triangle. You just can't assume the bases of each of these being 200 each. So what we're trying to find is the width of the river. So y, so the height of that triangle, basically. So first thing we're going to do is we're going to look at that triangle as a whole, and you are going to want to find out what this missing angle is right here. So even if you want to draw it out separately, so I've got 36 here, I've got 59 here, and I'm trying to find this missing angle. Sorry, that's supposed to be theta. Okay, reason why I want to find theta is because if I was to just go and use a primary trig ratio to find y, I don't have enough information. I only have an angle. I don't have any other sides, so I can't use a primary trig ratio. So I'm going to need to use acute angles first, and then try and get any missing information, and then I can use a primary trig ratio. So if I look at this, the triangle as a whole, that's an acute triangle. So I have a decision to make. I need to decide whether I'm going to use sine law or cosine law. I look at what information I have. I have two angles. Sorry, I didn't write this down. There we go. So I have two angles and a side. Of course, I don't have the side. I don't have the corresponding angle to that side, but I can simply solve that. I know that a triangle adds up to 180. So I can say 180 minus 59 minus 36 will give me angle theta, which is 85 degrees. So this is 85. All right, so I have all three angles, but in terms of which equation I'm going to use, because I have two angles and a side, I can use sine law. So remember, I need to have two of one of them. So I can either have two angles and a side, or I can have two sides and an angle. It doesn't matter. I just need three of those things, and I have to have two of one of them so that I can create a ratio. So I'm going to use sine law here. I'm going to call this, I don't know, A, B, C. I like to use ABC just because it's easier to work with. Come on, get into focus here. All right, sorry, I'm doing this on my phone. Okay, so the reason why I'm trying to find a missing side is because if I find a missing side, and it doesn't matter, I can find this side or this side, but once I have a missing side, these sides correspond to here. So once I have one of these missing sides, then I'm moving forward, because now I have an angle and one of those sides, and I can start working to find the height. The height of this triangle, or in this case, the width of the river. So I want to find either this side or this side to try and fill in more information here. So it doesn't really matter which one I do, whether I solve for this side or this side. I'm going to solve for this side anyway because I feel like it. So I'm going to solve for side B. So I'm going to take A over sine of A. And I'm picking A because this is the only side that I have, so I have to use this one. And I have B over sine B. Sorry, I'm going to shift that over a little bit. Okay. So A is 400 over the sine of 85 equals B, which is what I'm trying to find, over the sine of 59. Now, I'm not going to show the cross multiplying again because you should know how to do that now, and I've shown you in the previous question. So for the interest of time and space, I'm not going to do that. So when I solve for B, I would get 344.2. Okay, so that's B. So that would be this right here. So I'm going to add that over here. So this is 344.2. So now I have an angle, and I have a side, and I can find the remaining side. Easy. Right now I can use primary trig ratios because I have one of these sides. Right? It doesn't matter that I don't know what this side here is because I have this side. I have the hypotenuse and I have an angle. I just need to find that other side. So let's shift over and do that now. So I'm working with respect to this angle, so I need to look at what I have with respect to that angle. So I'm trying to find this. So this would be, in this case, in respect to 36 degrees, that would be the opposite. And I also have the hypotenuse. If I go back up to SOHCAHTOA that I wrote up here, the trig ratio that takes hypotenuse and opposite into account is sine. So I'm going to say sine of 36 is equal to it's opposite over hypotenuse, so opposite would be y, what I'm trying to find, and my hypotenuse would be 344.2. I cross multiply. y equals 202.3. So that means that the river then is 202.3 meters wide. Okay, another nice question because it takes both into account. And these are nice practice questions because it's asking you to do both in the same question. And rather than it just being a question that just does one or a question that does the other, it does both. So you actually have to make the decision on which formula to use based on what triangles you're working with and what information you have. So these are really nice practice questions. And if you can solve these questions, you're golden for the test on Friday. Let's move on. The swimming portion of a triathlon course is shown below. Find the distance they have to swim in total. So here's our start. I don't know how well you can make that out. So here's our start. This is 2.1 kilometers. This is 2.7 kilometers from this point to this point. This is an 86.9 degree angle. They are swimming in this direction because it's asking you to find how long they have to swim, which we're assuming is going to be X because that's our unknown side. I'm gonna make that a little bit darker. So this is really what I'm trying to find. So this is the start. This must be the finish. It's not labeled, but this would be the finish. So we're trying to see how far they have to swim. So we only have one triangle, so we're not working with two in this case. We just have the one, and we can clearly see that it is a acute triangle, right? Even though we only know one of the angles, we can tell by looking at it, there are no right triangles. There's no right triangles that are labeled, so we know that it is an acute triangle. So we can throw out the option of any primary trig ratios. That leaves me with sine law or cosine law. So in order for me to decide which one I want to use, I have to look at what information I'm given. In order for me to use sine law, I have to have two sides and an angle, or two angles and a side. Problem with that is, sorry, get into focus there. Sorry, I keep pausing it just to pull out my worked out one, and then when that happens I have to turn the camera back on and then it needs to refocus. So the problem with that, oh my god, is that even though we have two sides, there we go, even though we have two sides and an angle, we don't have the right ones. We don't have the corresponding ones. So yes, we have two sides, but we don't have their corresponding angles, and we have an angle, but we don't have that corresponding side. So it doesn't work. So if you look at this, when we talked in class yesterday, we looked at things like side, 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 angle, 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 side, side, angle, side. And depending on which of those you have will determine whether or not you have a sine law or cosine law. And I asked you yesterday to make a list of those relationships that you could look at and go, okay, I have side, angle, side, I need to use such and such. So if you look, we've got two sides and a contained angle. So two sides and a contained angle is called side, angle, side, right? And we looked at that yesterday. And if you go back to that list that I encouraged you to make yesterday, you should see that. So I've got two sides and a contained angle, side, angle, side. If I have side, angle, side, I use cosine law. Have to. Can't use sine law because even though I have two sides and an angle, it's not the right two sides and an angle. I don't have the corresponding angles with the sides. So I have to use cosine law. So we can label this triangle. So we'll just say A for the start. We'll put B over here. I'll make C the finish just to make it easier. So this would be side C, which is 2.1. This would be side B. So I'm just going to scratch off the X and just put a B. I'm still solving for the same thing. I just like to have them letters that work. And then I have side A over here. So we know that cosine law is written three different ways depending on what it is that you're looking for. So because I am looking for side B, I'm going to write it in relation to looking for side B. So we have, and again, you have to just know how to set these up. So we've got B squared. We're trying to solve for B. So we know it's going to be B squared equals the other two squared. So A squared plus C squared. So it kind of looks like Pythagorean's theorem to start. Minus 2 times the other two sides, so AC, multiplied by the cosine of the angle, which would be B. And I'm going to put that in brackets. Okay, so like I said yesterday, whatever side or angle that you're looking for, they will always bookend the equation. So the equation starts with b squared and ends with cosine of b, because that's what we're looking for, is b. And then everything else in between would be your other two angles. So you really don't have to memorize all three. You really only have to memorize one, and then it's just a matter of swapping the letters out. So b squared equals a squared plus c squared minus 2ac times the cosine of b. And now, again, it's just a matter of plugging things in. So I've got b squared equals a squared, which would be, we made side a 2.7, so 2.7 squared, plus c squared, which would be 2.1 squared, minus 2, and I'm going to put that in brackets because 2a and c are all being multiplied, so remember to use your BEDMAS correctly. So 2 times the side of a, which is 2.7, times side c, which is 2.1, I shift that over, times the cosine of b, which is 86.9. Now I've solved it all in one, pretty much all in one step. So again, just make sure you're using your calculator correctly. What I would do is take 2, multiply it by 2.7, multiply it by 2.1, and hit equals if you want, and then then multiply it by cosine of 86.9. Then you have a value, and then you can rewrite it. So you could have b squared equals 2.7 squared plus 2.1 squared minus whatever this value would be. Square these two values, add them up, and then do your overall subtraction to get a value. So just make sure that, or if you're putting it into your calculator and you want to do it all in one step, that's fine. Make sure you have a scientific calculator and you're putting brackets in. So you can go 2.7 squared plus 2.1 squared minus, and then as long as you're opening up and closing brackets around each of these, you can do it all in one step. Your scientific calculator will do it properly as long as you've opened and closed those brackets, because then it'll recognize BEDMAS. So what you end up with is b squared equals 11.09. In order to get b by itself, we square root both sides. So b equals 3.3. So we've got 3.3 meters. So this distance here is 3.3 meters. Just thinking about the question again, it's asking you to find the distance they have to swim in total. So I'm not sure if it's implying that they're swimming from here to here, here to here, and then here to here. That would kind of make a little bit more sense. I'm clearly not a swimmer. So if you interpreted it that way and you were to add all three sides as the total, that's fine. If you interpreted it in a different way and left it like that, like I did originally, it's not a big deal. But I'm thinking back now, I think that's kind of the point they were trying to get across there. Okay, so it's going from A to B, B to C, and then C back to A. So now that you know that this length here, you can add the three lengths up together. So 2.1, 2.7, and 3.3, which would give you 8.1. And that's not meters, that would be kilometers, which 8.1 meters wouldn't be very far. Okay. Last question. It says, Alex is making a triangular garden with side lengths 12 meters, 7 meters, and 8 meters. Find the measure of the largest angle between the sides. Okay, that's a nice one. So they don't give you a diagram here, so you have to draw it out. It's pretty easy. They're telling you it's a triangular garden. They're telling you the three sides. So we know, and again, it doesn't matter if this is proportion. You're just coming up with a diagram. So we've got 12, we've got 7, and we've got 8. And it also doesn't matter which side is which. So what you make 12, what you make 7, what you make 8. What it says is, find the measure of the largest angle between the sides. So when we look at what we're working with, again, it's an acute triangle, so we can rule out the idea of primary trig ratios. So we know it's an acute triangle, so we can use sine law or cosine law. We have no known angles, all we have are sides. So we've got side, side, side. So if you remember from yesterday, that means we would be using the cosine law. So it's asking us to find the largest angle between the sides. So you don't know which angle that is, so you would have to solve for all three angles. So you can start with one, then work to the other, then work to the other. So I'm going to make this A, B, and C. And we can start first by solving for, let's say, A. So again, you will possibly have to rearrange. If you know that your equation is a squared equals b squared plus c squared minus 2bc times cosine of A. You can rearrange this. Now, do not divide by all of this stuff because it's going to get things quite messy, and I think it's too complicated. What you can do is, because negative 2bc are all attached to cosine of A, they sort of move as a package. So what you can do is take this whole thing and move it over and swap it with A squared. So when you move something over, the sign changes, so you're left with 2bc cosine of A equals b squared plus c squared minus a squared. Okay, then you would divide by 2bc, divide by 2bc, so this is gone. So now we've got cosine of A equals b squared plus c squared minus a squared, all divided by 2bc, right? That would be the way you would rearrange. Okay, for you to, these things aren't all being multiplied. So you can't just divide by b squared plus c squared minus 2bc. That's incorrect. Okay, as long as these pluses are there, that prevents you from doing that because b squared and c squared aren't being multiplied by cos A. So by dividing that by those values, you're not negating them. You're not getting rid of them. You're supposed to do the opposites. So opposite of multiplying is dividing, which is why we divide 2bc to get rid of it. So when something's being subtracted, we bring it to the other side. Or when something's being added, we bring it to the other side. So you cannot divide by this whole entire thing. So you can't say a squared equals cos A divided by b squared plus c squared minus 2bc. No. You move this over, then you only have what's being multiplied by cos A that's attached to it. Then you can divide those guys out, and these guys are left alone. So now we have cosine of A, and we can solve for the right side. So cosine of A equals b squared, which it would be 12. And again, it depends how you number this. So 12 squared plus c squared, which would be 7 squared, minus a squared, which would be 8 squared, all divided by 2 times side b, which would be 12, times side c, which would be 7. So you would have to work those out. So we have 12 squared, which is 144, plus 7 squared, which is 49, minus 64, all divided by 12 times 7 multiplied by 2. Let me get out my calculator. Hold on. So that would be 168. Then when we simplify all of those together, we are left with 144 plus 49 minus 64 equals 129 divided by 168 equals 0.7679. Okay, notice that's a decimal. That's a trig ratio, right? You're not being given the actual value. So cos A equals 0.7679. It's the exact same thing as if you had, cosine theta and it gave you a decimal place, right? We're trying to find an angle. So you have to now use the inverse, right? It's the only other way you can solve this. You can't solve this. That's not an angle. You're not going to have an angle that small. That was a side, different story. But just like last week, when you have, when you're trying to find an angle and you're using primary trig ratios, you use the inverse. So the same thing applies here. Because you're given a decimal, that's a ratio, right? We divided two numbers. So we're given a ratio. So in order to find an unknown angle, so cosine of A, we would use the inverse. So be inverse of cos, and then 0.7679. So we have, I'm just trying to figure out how to do this on this calculator. Okay, and that gives us angle A equals 39 0.83 degrees, and that's approximate, right? Because it was quite a large decimal here, and I rounded it down to 4. So if you are cutting down the decimals, I would try and keep about 4 and make sure that you're indicating that this is an approximate value. If you're keeping the whole, if you have one of those calculators where you can hit something and then hit Shift ANS, so it takes like the answer value that you had and then plugs it into the next thing, then that's fine, because then it'll keep all those digits for you. If you know what I'm talking about, it's like a answer button, and it takes whatever answer you just had and carries it forward. If you don't have that and you're going to cut it down and leave a couple decimal places, then you should indicate that it's approximate, and that's what little squiggly line's for. So that would give me the degree value for angle A. So that would be up here. So it's what, 39 and 39 something. Okay, then you need to do the exact same calculation for B and C. So I'm not going to run through those because you can solve those on your own. You would just be solving for angle B and then solving for angle C. The exact same thing you would do, except you're just basically swapping out the letters. So if you're looking at B, it would be B squared equals A squared plus C squared minus 2AC cosine of B. So remember that the side or angle of interest is going to bookend the equation, and whatever's left would be in the middle. And then the fact that you're solving for an unknown angle, you need to rearrange like we looked at yesterday. So taking this, so cos of whatever angle you're looking at and everything that's attached to it by multiplication, and bringing it over to the other side and swapping it with this. These guys don't move with it because they're not attached by multiplication, and you can't divide the entire thing by all of these because these guys aren't being multiplied by cos A. Therefore, you can't divide to get rid of them because adding and dividing are not opposites of each other. So that doesn't work. Okay, so once you've rearranged your equation, you plug the numbers in and find your next angle. Okay, so that is pretty much our last lesson. So congrats to finishing the end of grade 10 math. So over the next couple of days, Miss Ryder will be giving you a list of practice questions for trigonometry. Make sure that you do them as thoroughly as possible. Email me if you have any questions, and I will try to help you as best as I possibly can through email. And your test will be Friday. So I suggest that you don't use the next 3 days as a chance to be chit-chatting like you normally do. Please use this time wisely, and you know that Miss Ryder will be sending me emails on your progress. We will be having lessons in Nashville. The 4 of us that are here, or the 4 students that are here with me, will be doing this exact same thing in Nashville. So you don't want them having an advantage over you because they are with me. Right? They're doing the exact same stuff as you. I'm teaching them the exact same way. The difference is I'm here to make sure they're doing work, so you need to take the responsibility to do the work yourself. Other than that, we will miss you, and we will see you next week.